Chapter 4, Factors and Fractions. Determine whether 435 is divisible by 2, 3, 5, 6, or 10. Look at them one by one. The number 2, you look at the number 435 and you immediately know that the ones digit is 5, and 5 is not divisible by 2, so the number cannot be divisible by 2. The number 3, if you add 3 digits together, the sum is 12, and 12 is divisible by 3, so you know that the number is divisible by 3. 5, the ones digit is a 5, so you know that it is divisible by 5. 6, no, 435 is not divisible by 2, so it cannot be divisible by 6. And 10, no, the ones digit is not a 0. This would have to be a 0 for it to be divisible by 10. Determine whether 786 is divisible by 2, 3, 5, 6, and 10. Use the same method. The last digit is divisible by 2, so you know the number is divisible by 2. So 2, yes. Add the numbers together. 7 plus 8 is 15, plus 6 is 21. 21 is divisible by 3, so you know the number is divisible by 3. The last digit, the ones digit, is a 6. A 6 is not divisible by 5, so you know the number is not divisible by 5. The number is divisible by both 2 and 3, so you know it is divisible by 6. And the last digit, the ones digit, is not 0, so it is not divisible by 10. So 2, 3, and 6. Sonia is running for student council president. She wants to give out campaign flyers with a pen to each student in the school. She can buy Vote for Sonia pens in packages of 5, 6, or 10. If there are 306 students in the school and she wants no pens left over, which size package should she buy? Should she buy the size 5? No. She doesn't want any left over, and 306 is not divisible by 5, or 0, or 10 because the last digit is 6. Size 6. Yes, 306 is divisible by both 2 and 3, so you know it is divisible by 6. Therefore, there would be no leftover pens. 10. No, the last digit is not 0, so she would have leftovers. Sonia should buy pens in packages of 6. A class of 72 students is taking a field trip. The transportation department can provide vans that seat 5, 6, or 10 students. If the teacher wants all vans to be the same size and no empty seats, what size vans should she use? Well, we immediately know 72 is not divisible by 5 because the last digit, the ones digit, is not a 0 or a 5. So 5, no. 6, we know that 72 is divisible by 2 because it ends in a 2. And we know it's divisible by 3 because 7 plus 2 is 9. So we know that 6 would factor into 72. And 10, the last digit is not a 0, so we know it is not divisible by 10. So she would want vans of 6. List all of the factors of 64. Use the divisibility rules to determine whether 64 is divisible by 2, 3, 5, and so on. Then use the division to find the other factors of 64. 1. Yes, factors of pairs. 1 times 64 is divisible by 1. 2. Yes, 2 times 32. 32 times 2 is 64. 64 divided by 2 is 32. 3. 6 plus 4 is 10. 10 is not divisible by 3. It is not divisible by 3. 4. Yes, 16 times 4 is 64. 5. No, the ones digit is not a 5. 6. No. It is not divisible by 6. 7, no, it is not divisible by 7. 8, yes, 8 times 8 is 64. So the factors of 64 are 1, 2, 4, 8, 16, 32, and 64. 32 times 2, 16 times 4, 8 times 8, 4 times 16, 2 times 32, 1 times 64. 64 times 1. These are the factors. List all the factors of 96. They're listed right here for you. 91 times 96 2, we know that it ends in a 6, so it's divisible by 2. 3, 9 plus 6 is 15, so we know it's divisible by 3. 4, it's divisible by 4, divisible by 2. 6, it's divisible by both 2 and 3, so it's divisible by 6. It's divisible by 8, 12, 16, 24, 32, 48, this is half of 96, and 96. These are all of the factors of 96. Determine whether 4n plus 3 is a monomial. 4n plus 3, distribute it out, 4n plus 4 times 3, 4n plus 12. This expression is not a monomial because in its simplest form, it involves 2 terms that are added. A monomial is 1 term. Mono means 1 term. Determine whether x over 3 is a monomial. This expression is a monomial because it is a product of a rational number, 1 over 3, and a variable x. There is only one number. Nothing's being added or subtracted. One number. Determine whether each expression is a monomial. 7ab. Yes, in its simplest form, it is 1, 6, 4 minus x. Not a monomial. In its simplest form, 6 times 4, 24, minus 6x. There are 2 numbers involved in here. It is not a monomial. Monomial is 1. 7ab is a monomial. 24 minus 6x is not a monomial. End of lesson 4-1. Write 6 times 6 times 6 times 6 using exponents. Well, the base is 6, and it is a factor 4 times, so the exponent is 4. 6 to the 4th power. 6 times 6 times 6 times 6. Can also be written 6 to the 4. Write p using exponents. Well, the base is p, is a factor 1 time, so the exponent is 1. P to the 1. It's not multiplied by anything. It's not multiplied by itself multiple times. It is just p. P to the 1. Write -1 times -1 using exponents. Well, the base is -1, so the number on the bottom, -1, and it is a factor 1, 2, 3 times. So the exponent is 3. -1 to the 3rd. 5x plus 1, 5x plus 1. As exponents, there are 2 of the same number, so the base is 5x plus 1, and you put 2, or squared. That means 5x plus 1 times 5x plus 1. It is factored twice. Write each expression using exponents. 1/2 times x times x times x times x times y times y times y. First, group the factors with like bases, then write using exponents. So we have 1/2, 4 x's, 3 y's. So we know it's x to the 4, y to the 3, and we keep the 1/2 the same. 1/2 x to the 4, 1, 2, 3, 4, y, 1, 2, 3, 3 y's. This is the same as writing it like this. Write each expression using exponents. 3 times 3 times 3 times 3 times 3 times 3. Well, they have the same number, 3, so 3 is the base, and the number of times it is present is the exponent. 1, 2, 3, 4, 5, 6. 36. 4 minus 2x times 4 minus 2x. Well, base is 4 minus 2x, and it appeared twice. So 4 minus 2x squared. M times m times m, m cubed, m to the 3. M is being multiplied by itself 3 times. -6 times -6 times -6 times -6. -6 to the 4th. 1, 2, 3, 4 times it showed up, so it is -6 to the 4th. 9a, b, 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 b. We have 9a 1, 2, 3 times, a to the 3. b 1, 2, 3, 4, 5 times, b to the 5. We just write it out, keep the 9 the same, and write how many times A appeared and B appeared. That's the exponent. Write 235,016 in expanded form. Step 1, use place value to write the value of each digit in the number. 235,016 is 200,000 plus 30,000 plus 5,000 plus 0 plus 10 plus 6. So we have 2 times 100,000, 3 times 10,000, 5 times 1,000, 0 times 100, 1 times 10, 6 times 1. Now write each place value as a power of 10. So we have 2 times 10 to the 5, 3 times 10 to the 4, 5 times 10 to the 3, 0 times 10 to the 2, 1 times 10 to the 1, 6 times 10 to the 0. We just broke it down into numbers: 200,000, 30,000, 5,000, 0, 100, 10, and 6. This is what we broke it down to. This is the numbers, and these are the standard notation of it. Now, express 24,706 in expanded form. Well, it's 20,000 plus 4,000 plus 700 plus 0 plus 6. 20,000, 2 times 10 to the 4. 4,000, 4 times 10 to the 3. 700, 7 times 10 to the 2. 0, 10, 0 times 10, 6, 6 times 1. 2 times 10 to the 4 is 2 times 10 times 10 times 10 times 10. So that's 1, 2, 3, 4 zeros. 1, 2, 3, 4. 20,000. Evaluate 4 squared. 4 squared is the same as 4 times 4. 4 times 4 is 16. 4 squared is 16. Evaluate r cubed minus 3 if r equals negative 2. Substitute this negative 2 in for r. So now it's negative 2 cubed minus 3. Negative 2 times negative 2 times negative 2 is negative 8 minus 3 is negative 11. So the answer is negative 11. We just replaced r with negative 2, and negative 2 is a factor 3 times. Evaluate x, y plus 2 squared if x equals 2 and y equals negative 2. Replace x with 2 and y with negative 2. 2 times negative 2 plus 2 squared. Negative 2 plus 2 is 0. 2 times 0 squared. 0 squared is 0. 2 times 0, 0. The answer is 0. Anything multiplied by 0 is 0. Evaluate each expression. 3 to the 4th, 3 times 3 times 3 times 3. You see that there's a 4 right here, so you know it's multiplied by itself 4 times. 81. 100 minus x to the 4 if x equals 2. 100 minus 2 to the 4th. 100 minus 2 times 2 times 2 times 2. Answer is 84. M, 5 minus n 3 if m equals negative 3 and n is 3. Substitute them in. Negative 3, 5 minus 3 cubed. 5 minus 3 is 2 cubed. Negative 3. 2 cubed, 2 times 2 times 2. 8. Negative 3 times 8. Negative 24. End of lesson 4-2. Determine whether 31 is prime or composite. Find factors of 31 by listing the whole number pairs whose product is 31. 31. 1 times 31. The number 31 has only 2 factors, 1 and itself. Therefore, 31 is a prime number. If it only has 2 factors, 1 and itself, it is a prime number. Determine whether 36 is a prime or composite number. Find the factors of 36 by listing the whole number pairs whose product is 36. 36 is 1 times 36, 36 is 2 times 18, 36 is 3 times 12, 4 times 9, and 6 times 6. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, 36. Since the number has more than two factors, it is a composite number. Prime number only has two factors, composite numbers has three or more. Determine whether each number is prime or composite. Well, we know 1 times 49. We know 49 cannot be divided by 2. We know it cannot be divided by 3. So it cannot be divided by 4, cannot be divided by 5, but it can be divided by 7. 7 times 7 is 49. It is a composite number. 29. 29 can only be multiplied by 1 and itself. There are no other numbers, so it is a prime number. Two factors. 49 has three factors, 1, 49, and 7. 29 only has two, 1 and 29. Write the prime factorization of 56. 56 is at the top. The prime factorization is complete because 2 and 7 are prime numbers. 56, 8 times 7. 4 times 2 is 8. 7 stays the same. 7 is a prime number. 4 times 2, 2 times 2, 2 stays down. All we do is factor 56 down so we have only prime numbers at the bottom. The prime factorization of 56 is 2 cubed times 7. There are 3 2's, 1 7. Write the prime factorization of 72. We'll have 72 we can have 9 and 8. 9 times 8 is 72. 9, 8. From there we can have 3 times 3. And from 8 we can have 4 and 2. 3 stays the same. 3 stays the same. 4 becomes 2 times 2. And 2 stays at 2. So we now have the prime factorization of 3 times 3 times 2 times 2 times 2. And we write it as 3 squared, there are 2, and 2 cubed. There are 3 2's. Prime factorization of 72 looks like this. 2 cubed times 3 squared. Factor 16p squared q4. 16p squared q4 is the same as 2 times 2 times 2 times 2, p squared times 2 cubed to the 4. So we have 2 times 2 times 2 times 2 times p squared is 2p's, q4 is 4 q's. So the answer is 2, 2, 2, 2, pp, q, 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 q. That is the factor. Factor negative 21 x squared times y. Negative 21 x squared times y. Negative 1 times 3 times 7 times x squared times y. Negative 1 times 3 times 7 times x times y. The answer for the factor of negative 21 x squared is negative 1 times 3 times 7 times x times y. 12 a cubed times b. 2 times 2 times 3. A 3 times, b 1. Negative 18 mn squared. Negative 1 times 2 times 3 times 3 times m times n times n. Prime factorization is all we did for these. End of lesson 4-3.